Welcome to the Explainer. Today, we're taking a highly technical safety manual and transforming it into a rapid-fire, tactical battle plan for fighting fires. We're going to break down exactly what you need to know about extinguisher performance, deployment protocols, and literally the science of stopping a fire dead in its tracks. By the time we're done here, I promise you, you'll look at that red canister on your wall in a completely different light.
Okay, so here's our game plan for today. First, know your enemy. 2, the science of the strike. 3, choosing your weapon. 4, heavy artillery, deploying foam. And finally, number 5, the final stand. We've got a lot of ground to cover, so let's just dive right in.
Section 1. Know your enemy, the classes of fire. Look, before we can even think about fighting, we have to identify exactly what we're up against, right? You literally cannot defeat a hazard if you don't understand it. So the manual breaks down our 5 distinct enemies. Class A fires are your ordinary combustibles. Think of your everyday environment: wood, paper, cloth, plastics. Class B, that's your flammable liquids and gases like oil, grease, gasoline. Class C is energized, live electrical equipment. We're talking electrical panels, exposed wiring. Then there's Class D, combustible metals like magnesium, titanium, and lithium. And finally, Class K, which is commercial cooking equipment involving massive amounts of animal fats and vegetable oils. But here is the absolute crucial takeaway. You've got to understand the unique threat level of Class D and Class K fires. If you run into burning metals or commercial kitchen fats, you are facing exceptionally high heat that crosses into what professionals call an IDLH situation. That stands for immediately dangerous to life or health. These are definitely not your standard wastebasket fires. They require extreme caution and highly specific responses. Moving on to Section 2, the science of the strike, how to kill a fire. So, now that we actually know the enemy, let's look at the scientific mechanisms we use to destroy it. Every single weapon in our arsenal attacks a fire using one of 3 foundational methods. You can cool it, literally dropping the burning material's temperature below its ignition point. You can smother it, completely cutting off its oxygen supply and basically suffocating the combustion process. Or you can engage in chain breaking. This is where you physically interrupt the chemical chain reaction that allows the fire to keep itself going in the first place. And that actually brings us to a really incredible tactical vocabulary word: saponification. Saponification is this highly specific scientific process where the extinguishing agent smothers the fire by turning its surface into a thick, oxygen-excluding, soapy shield. It's a wildly effective way to trap the hazard and neutralize the threat, especially in commercial kitchens or hot oils are involved. All right, Section 3, choosing your weapon, the arsenal. With the science locked in, it's time to look at the exact agents inside those red canisters. Because honestly, choosing the wrong one isn't just ineffective, it can be downright deadly. There's a vital difference in our arsenal depending on what you grab. Take a basic water extinguisher, for example. It is fantastic for Class A ordinary combustibles, but completely useless and actually highly dangerous if you use it on grease or live electrical fires. Now, compare that to a versatile dry chemical extinguisher loaded with monoammonium phosphate. That single canister is chemically designed to safely knock down Class A, B, and C fires all at once. Talk about a real game changer. We also have specialized tools, like clean agents. These have stepped up to replace older, environmentally harmful halon chemicals. So newer agents like Fe36, HFCs, HCFCs, and PFCs are designed to safely combat multi-class fires without leaving a single trace of damaging residue behind. Why does that matter? Well, if you're protecting a multi-million-dollar server room or a hospital wing with super sensitive electronic equipment, a clean agent is absolutely your best friend. Now, your physical safety margin is entirely dictated by your weapon's range. A water extinguisher lets you stand a comfortable 40 feet away from the blaze. A dry chemical unit, that cuts the distance in half, giving you about 20 feet of operational space. But think about the CO2 extinguisher. Grabbing a CO2 tank means you have to get dangerously close to the flames, usually within 3 to 8 feet, for it to be effective. You have got to know your weapon's range before you engage. So let's test your knowledge for a second. Imagine you're face-to-face with a massive grease fire in a commercial kitchen. Do you know which canister to grab? Well, if you said a wet chemical extinguisher loaded with potassium acetate, you'd be absolutely right. It is literally the only agent specifically designed for those IDLH Class K kitchen battles, and it's built to suppress that fire for a massive 75 to 85 minutes just to prevent reignition. Moving right along to Section 4, Heavy Artillery, Deploying the Foam Line. Now we're going to step into the boots of the professionals and look at the intense protocol for setting up a heavy-duty foam line from a fire apparatus. Before a single piece of equipment is even touched, the operator has to verbalize a strict safety checklist. I am in full PPE. I will let the incident commander know. I will notify the crew. I will work uphill and upwind. I will shut down utilities. I will find a second means of egress. Doing this ensures the operator is fully protected, communicative, and tactically positioned away from the hazard's path before the operation even begins. Once cleared to proceed, the operator selects the foam. You cannot just guess the mixture here. You have to precisely adjust the inline educator metering valve to match the exact fire type. A standard Class A fire only needs a 1% concentration. Hydrocarbons, they can range from 1 to 6%, but if you're facing a polar solvent fire, you have to scale that metering valve all the way up to 6% to effectively break down the chemical threat. Setting this up is a precise, tactical dance that follows a strict chronological procedure. First minute, you bring the hose and confirm the order. Second minute, you connect the reducer, verbally confirming you're checking for debris in a black gasket. Minute 3, attach the adductor and set that metering valve. And finally, minute 4, attach the nozzle, charge the hose line, open the nozzle fully, and call out water, water, water to agitate the foam. It has to be completely methodical. And there's a magic number here, and it's all about gravity. That number is 6. When you're placing the adductor suction hose into the foam concentrate, it cannot be more than 6 feet above the liquid surface. If you place it any higher than that, the physics of the siphon just fail, and the system simply won't pull the foam concentrate up into the hose line properly. Once the foam is flowing, the absolute golden rule is you never shoot it directly into the fuel. That would cause a disastrous splash and spread the fire instantly. Instead, you use one of 3 tactical methods to safely blanket the hazard. You can bank it down by hitting a wall and letting the foam bounce onto the fire. You can roll it by hitting the ground in front of the fire so it rolls right over the top. Or you can rain it down by pointing the nozzle up and letting the foam gently fall onto the hazard. All right, our final section, Section 5, the final stand, using your extinguisher. Let's scale things back down to the everyday user and look at exactly how to operate a standard portable extinguisher during an incipient or early stage fire. Before you just charge into the heat, the manual demands a few vital pre-attack steps. You have to quickly verbalize the fire type to confirm your extinguisher is actually a match. Then, point the nozzle in a safe direction and discharge a short, quick burst just to test that the unit works. Finally, if you're outside, you must always approach the fire from the windward side, meaning the wind is at your back, pushing the extreme heat and smoke safely away from you. In moments of high stress, you really need a physical mnemonic for rapid deployment, and that is the universally recognized PASS technique. P, pull the pin, unlocking the mechanism. A, aim the nozzle directly at the base of the fire, not the flames up above it. S, squeeze the handle to discharge the agent. And S, sweep the agent side to side to entirely cover the width of the fire. Just remember, pull, aim, squeeze, sweep. Now, one of the most catastrophic mistakes you can make is plunging the pressurized agent directly into a liquid Class B or a grease Class K fire. That pressure physically splashes the burning fuel, spreading the inferno instantly. Instead, just like the heavy foam lines we talked about earlier, you must always allow the agent to gently rain down onto the fuel surface or softly deflect it off a nearby object. Even after the flames are gone, the battle isn't quite over. You still have to use extreme caution. You never turn your back on a defeated fire. You cautiously back away, step by step, keeping an eye out for dangerous reignition. If it was an electrical Class C fire, you disconnect the power source immediately, assuming it's safe to do so. Finally, properly tag the spent extinguisher for recharge and explicitly lay it flat on its side so nobody in a panic mistakes it for a fully charged unit. I'm going to leave you with this critical thought. Knowing that using a water extinguisher on a grease fire or an electrical panel can make the situation exponentially worse, are you absolutely certain you know what is inside the canister down your hallway? Seriously, the next time you walk past a fire extinguisher, take just 3 seconds to stop and read its label, because choosing your weapon correctly is the very first step to survival. Thanks for joining me on this explainer.